Hello, welcome to my YouTube channel. Right, this is one of the simplest projects that you can do for the start, for maybe training or for social upliftment in the community. This is basically a project that uses as much waste material as possible. What I've done is I've picked around old LED lights and computer power supply enclosures and a defect or thrown away car cell phone chargers, and then here and there picked up some components, transistors and all that small components, and then I produced a rechargeable LED light from a thrown away laptop batteries and also thrown away cell phone batteries. Well, I think this is the project with the most recycled material. Well, I think the circuit is very simple and straightforward, but before then, as always, electronic waste benefit. Please remember, electricity can kill. Work experience in electricity required. If you don't, you get someone who can actually help you on that. I expect that the people who are doing these projects already have electronics background or can actually read circuits. Keep working and equipment out of reach of children, of course, and minimum age expected 10 years and above. Right, this is just an explanation or description of how I've done my projects, and it's not an electronic lesson. And for this project, of course, the electronic waste benefit is being used to the highest percentage. And there are many ways of doing it. You can also correct, adapt, modify, improve these circuits, and you can use them for training, you can use them at home, you can use for production. Right, and required materials, of course, soldering irons and meters and all that. And I expect that you have your time, you have patience, you have passion and dedication. Feedback, please, tauramirime@gmail.com. Thank you. Let's go on to my explanation. Right, this is what you get from the most cell phone car chargers, the chargers that are used in the cars. This is the IC that does the job, the MC34063. You take out that IC, you build your own circuit. This is a DC to DC converter. You can use different DC to DC converters, of course, but this is normally an IC you get thrown away, or the circuit that you get thrown away, modified to get a working circuit. Normally that circuit is usually working. Normally what is defect on those chargers is the cabling, the cables that actually connects to the cell phone. And this diode, please, it's just to prevent reverse polarity, and this diode must be able to handle the current because this is the feed diode. And then the transistor, that size plus or minus, which means you can get an equivalent. This diode is big also, must be able to handle I think 2 amps continuous, 2 to 3 amps continuous. The inductor also must be able to handle that much current, and you because you are actually charging this battery, and this battery is a lithium ion battery. You can try the nickel metal hydride or nickel cadmium batteries, but these days lithium ion batteries are common. The small batteries in cell phones, those batteries in laptops. Because when a laptop battery goes defect, it's not all the cells or all the batteries that are defect. We will normally get 2-3 out of they are normally 4-6 batteries. You know, those long cylindrical battery. I think it's 18650. The number for the battery. Right. So you have a DC to DC converter here that actually you regulate it down to 8.4 volts, because when it's charged it gets to 4.2 volts each, and you have two of them in series. You can parallel a number of them, I think up to the limit of your inductor and transistor diode current handling capability. Normally I use 4, meaning 2 parallel sets. You can get to 3, I think, with that size of transistor. Right. So you regulate it to 8.4 volts output, meaning you have to consider this diode drop, meaning 8.4 plus 0.6 volts of this diode. Right. This diode is basically just to prevent back current. You can put it here like that, or you can put it here to prevent back current. That's the simplest way of preventing back current. Here you can use solar supply, a 12 volt solar supply, or you can use a power supply to charge the battery. Right. Yeah, DC to DC, get a data sheet of the MC34063, and then here you have an oscillator. Here, this oscillator basically is first to save power, because the LED is set here is only on half of the time, meaning this is oscillating on off, and this is the frequency setting, and then your transistor for switching, and here is the on off switch for the light. Light on, light off. So if it's on, you power the oscillator starts running, and then your LED comes on. So save power, also save the LED life. It will save the LED life. The LED, 2 of them, because these are white LEDs, they require at least 2.5 volts for them to come on, and 2.5 up to maximum of 4, I think, volts. So 2 of them, meaning that 2.5, that's 5 volts minimum, 4 volts maximum, 8 volts. You can get up to 10 volts because it's actually switching, so they won't blow up, because they are only on for a very small time depending on your frequency. So your frequency should be high enough to actually prevent a flicker. You don't have to see them flickering. So this is very simple. All this, much of the components are recycled material, picked up material. So what I've done is I've actually used a different oscillator here, but basically the same circuit, and this is the other circuit with a different oscillator. You can use a different DC to DC converter here. Only your voltage should matter, and also here your input voltage, it must be able to handle the solar voltage up to 25 volts input, and minimum you can, it should also be able to run it around 3 volts minimum, plus minus. It also, maybe if you would get a DC to DC converter with the under voltage lockout, the best. Right. This is an NE555 timer oscillator. So, well, I think there's various circuits with this oscillator, so I think I'll save time on explaining how this works. It's just a different oscillator, almost plus minus the same frequency to light up these LEDs on. The oscillator starts to run and the LEDs come on. That's it. So I think it's the simplest circuit that you can do, but with huge impact. I've used this light on my chicken project. I was doing a chicken project, and this light with a set of how many batteries did I use? 1, 2, 3, 4. There were 4. The laptop batteries, the 18650 battery, there were 4 of them. They would last. I was switching them at 1830. They would last up to 4-5 a.m. the next morning. That was night lighting for my chickens, the broilers. I had 50 broilers that I was using, that I was actually keeping. So this light was okay. It would actually give enough light for the night. So there were 4 batteries, meaning 2 sets of series parallel setup. I've also another light that I've used is cell phone batteries. You just take them up, but the most important part is here only 8.4 volts for 2 LEDs, and you're regulating. You can actually use 3 and then you change your voltage here. 3 batteries. You still can try with these 2 for 3 batteries, but I think the best setup is 2 batteries, 2 LEDs, because each battery is 3.7 volts, and that LED is fully on and very comfortable with 3.5 volts. And so this is 3.7 volts, the lithium ion battery each. So 3.7, that's 7.4 volts, and you have your 7.4 volts. So sorry, this is 3.5, that's 7 volts. Here you have 3.7, plus minus almost equal. So that's why I used 2 lithium ion batteries with 2 LEDs here. So your setup can change to suit what you have. So this is one thing that I wanted to share. You can actually produce this one for the community, especially those people who are actually in the rural areas, or you can use for lighting for students for study, usually in the rural areas also, where there is people who are not on the grid, who are not on national electricity supply. They can actually do this out of picked material, recycled material, cell phone batteries, laptop batteries, small batteries thrown out. And these days you have a lot of LED lighting. You can just get working LEDs, because normally you'll find 1-2 out of the 10 or so LEDs still working on a thrown away torch. And here, cell phone charger for the cars. There is a lot on the market being thrown out. Transistors and all these other ones are thrown away, boards, PCBs, and then the enclosure, the computer power supply, would actually do the job very well. It still has a switch, or most of them actually, the old computer power supplies, they have a switch on there. You can actually use that one. So this is it. I think That's all. Thank you very much, and please feedback taurayamirim@gmail.com. Thank you. Enjoy your electronics.